as I said, SD-WAN components. I hope I'm audible and my screen is visible.
Yes, you're audible and screen is
Okay.
also visible.
Now, the section actually introduces you with the working infrastructure or architecture of how each and every component in this SD-WAN fabric works. We have data plane, which we will discuss about. Then we have management plane, we have control plane, and we have orchestration plane. These are the four planes, combining all of which we get SD-WAN fabric as an outcome. And it is a bit different than how traditional networks actually work. So in traditional networks, the management plane, the data plane, and control plane are all on same device. Mostly something that we discussed yesterday. And together, they facilitate communication within the network. So as I said, on a traditional device, we generally have components like we have line cards, then we have CPU, and then we have CLI or GUI, by using which you basically form up a device so that it can actually forward the traffic. Line card definitely playing role in order to forward the traffic. CPU playing the role in order to calculate the best path, and CLI or GUI in order to be able to configure how the CPU should perform. So this is our traditional management plane. This is your traditional control plane, and that's your traditional data plane.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
Each router in a network has these three components. Now, when you look at a traditional network, let's say you have number of routers, and each of which needs to be programmed independently to achieve the desired operational state of your network. So, and as the network gets larger and larger and larger, the amount of human intervention that is required to configure the topology dramatically increases. So, for example, if you have a scenario like this, I think I explained to you yesterday as well that if you have R1 which has around three neighbors, and then all of these three are connected to another network, and this has a loop back like 50.x/24. When the network is going to be advertised, it is going to be learned by all these other devices. And then these devices would propagate that particular route further. But before that, R2, R3, and R4 also did configure the or did calculate the best path selection. And after they came up to the answer, then they started advertising those particular routes out. That's how it works. If I add some more devices, maybe R6 over here and R7, and then create a connectivity with this in this way, then you can see how big the network would be. So the 50.0 network will be advertised out, and then R2, R3, and R4 will have to advertise it over here, over here, over here. Then this over here, over here, over here. Make sense? So as the network keeps on growing and growing, the amount of calculation increases, which actually adds more overhead onto the calculations that a CPU needs to do of a specific device. So increasing network requires your routers to have necessary available CPU and memory requirement to process these updates, which in turn like creates lots of overhead, as I said. Now, SD-WAN works in a different way, however. In SD-WAN, the architecture looks in some of the way that the first layer is actually your controllers. So you basically have SD-WAN controllers in one of the scenario, which will basically have vManager, then you will have vSmart, and then you will have vBond. This all is kind of into one picture. And after this, you basically have multiple types of transport. So you can have internet transport, or you can have MPLS transport, or you can have something like 3G or LTE as your transport. So transports can be anything, and it doesn't require you to only use a certain transport, unlike legacy networks. That in order to be able to connect to your site, you must go for uh, MPLS so that you can ensure the site-to-site connectivity or things like that. Now, if I say that these are our ISPs, and your controllers are connected to the ISPs in any of the ways. You say connectivity is over here, here, here. Okay, to all of them. Then you can set up your branches. So if you have your WAN Edge router that is situated in London, similarly you have your WAN Edge device that is situated into USA. You have another branch that is situated into Dubai, and you have another branch that is situated into Delhi. And let's say the USA is headquarter. So what do is you actually connect most of these branches with these, and then these would probably have connectivity to these. So how you work with it is you probably are looking forward that employees are sitting right away over here, right? These are your employees, and you want these employees to communicate with each other, correct? And from here to here, from here to here, from here to here, then from here to here, from here to here, here. There should be communication between all of them throughout. But that communication actually needs to be done via any of the transport. You cannot just directly like lay a cable between them and then make a communication possible. It cannot work like that. You need to go through your ISP. So what happens is it is only the data plane that actually exists onto the endpoints. There is no control plane or management plane that actually exists onto these endpoints. So the control plane is managed by this. The vSmart manages, oh, I'm sorry, I made a mistake. The management plane is managed by this. The vSmart manages the control plane, and vWAN manages the orchestrator plane. Everyone has their own responsibilities, and the architecture kind of differs from traditional networking. It allows you to support large scale networks while reducing the operational and computational overhead, because the control plane knows about all the routes and nodes of the network. You have to calculate the routing table only once. For example, if you're going to have a prefix like 10.x.x.x, so if you have a network like this, and then here you have 20.x.x.x, and then 30.x.x.x, and 40.x.x.x, all of these networks will actually won't be advertised out over here directly, or to this or to this. That's not the advertisement that it's gonna go through. Your vantage will only advertise the 10.0 network to the control plane, vSmart. Then vSmart will advertises over here, and over here. And you can push a policy, and you can say, for example, you don't want 10.x network to be advertised out to Delhi. So you can tell your vSmart that whenever a route from site number one comes up, do not advertise it out to Delhi office. No, don't advertise that. By default, it is going to advertise that, but you can definitely push a policy to not let your controller advertise those routes received from specific site to other specific sites. Once these advertisements are done, then your traffic will actually flow between the direct tunnels that they are going to maintain. So it's like the communication doesn't go via this to vSmart and to this. It just goes out to the transport and then returns back because the tunnels are maintained in this way, right? That's how the IPsec tunnels are going to be maintained, either on any of the transport. It doesn't require only MPLS to create a tunnel, but all of your tunnels can actually be created with any of the transport, meeting the same level of security. Security is also not a concern. So people do have misconception that SD-WAN is going to replace MPLS. Well, the clear answer is no. SD-WAN is not going to replace MPLS. You are still going to require MPLS because of the quality of bandwidth and the quality of service that it provides you. It's you cannot really rely on commodity internet or some other type of ISPs or transports to achieve the same level of performance. So you can, however, depend on to the commodity internet or 3G or cellular networks when the data is not latency sensitive. But if it's a latency sensitive data, then you probably would require a trustable transport to be there into your fabric so that you can use it. Make sense? Do you understand the overall idea about the architecture, that how it is divided? Now, how do they communicate, and how does the data link communication work? So, which are the tunnels that are formed? All of that we're gonna talk about just coming up. But this is I'm talking about the architecture. Do you understand the separation of them? So let's start with data plane, and understand how data plane actually works. Now, traditionally, the data plane is actually composed of physical interfaces, okay? Which means your WAN edge. The data plane actually resides onto WAN edge. And there are two types of devices that can actually be your WAN edges. When we say WAN edges, one is it can be your Cisco IOS XE devices that can be your WAN edge. Otherwise, it can be your Viptela OS devices that can be managed. So if that's a Cisco IOS XE series device, we call it a cEdge. And if it's a Viptela device, we call it as a vEdge. But both of them can be referred as WAN edges. You cannot have any other device apart from these two platforms as part of your SD-WAN fabric. If you want to connect a WAN edge within the SD-WAN, then or Cisco SD-WAN, then you must have one of these two devices or one of the devices which are based on one of these two platforms. Then and then only you will be able to connect them. Now, which are the device models that are supported on them? The devices that can actually become part of your fabric are categorized into three categories probably. The first category is for Cisco's devices. So you can say Cisco IOS XE physical devices. And then you have Viptela OS physical devices. And then you have Cisco and Viptela virtual devices. So in the IOS XE, you can have Cisco ISR, I think 1000 series. Then you can have Cisco ISR 4000 series, and you can have Cisco ASR 1000 series devices, which can actually be part of your fabric. Talking about Viptela devices, there are some additions as well. I think ASR 8000s, sorry, ISR 8000s can also become part of your fabric nowadays. They have launched the support for that. Then on the Viptela OS, you can have Viptela 100 series devices, Viptela 1000 series devices, and Viptela 2000 series devices. and 5000 series devices. These are the physical devices from Viptela that can actually become part of your fabric. And then talking about the virtual appliances, you can have CSR 1000V, then ISRV. Both of them are Cisco, and you can have vEdge Cloud, which is another virtual appliance made by Viptela that can be part of your fabric. These are the devices which can actually act as WAN Edge. You cannot have Juniper or Palo Alto or any other device that can become part of your fabric. These devices can be placed on-prem as well as on cloud. You don't really require them to be placed on site only. You can also have host them into solutions like Azure, AWS, or Google Cloud Platform. You can also host them into CSP as well, Cisco Cloud Service Platform. So Cisco also has its own cloud service platform like Azure and AWS. You can host them over there as well. Now, when you look at these advantages, the advantages needs to be upgraded to iOS XE SD-WAN edition. So if you have like Cisco iOS XE devices from the legacy networks, you cannot just say that the same legacy devices with the same OS can actually become part of the fabric. Those devices definitely have the ability to get connected to the SD-WAN fabric. You don't need to scrap them, but you need to perform an upgrade or update the iOS to SD-WAN edition, and then you would be able to make them part of the fabric. That's something that you need to take into consideration. Also, while considering which manage to go with, whether you should go with Viptela or with Cisco, then for this you will need to understand your throughput requirements or your data plane tunnel requirements. For example, how many other branches the router will be communicating with, and what type of interfaces are needed. Like Cisco vEdge, which means Viptela devices, they support Ethernet, LTE, and wireless interfaces. But the iOS XE, which means cEdges, they support platforms such as like voice and serial interfaces, right? And both platforms are interoperable on the SD-WAN fabric. You can have some of the sites having Viptela, some of them having cEdge, all of them having cEdge, or all of them having Viptela. That's completely your choice. No need to go with any specific mode of the device. You can have any combination of that. We were going to talk about how the data plane actually establishes a communication between both of them. So each router actually, whenever you place them into the data plane, let's say this is your site in London and this is your site in Dubai. So you have a vantage and you have another vantage, and then there is a transport, maybe iNet. So you connect your vantage to iNet and you connect your manage to another another connection to the iNet. What happens is your vantage is going to form up a data plane connection. That data plane connection will mostly be an IPsec tunnel. Okay, which means that if you have any LAN segment 10.x.x.x and 20.x.x.x, and they want to communicate with each other, the communication will only happen via this IPsec tunnel. Okay, which means that the in the other way, you can say that in the iNet fabric, in the ISP cloud, there are hundreds of routers, right? That will be there to connect London with Dubai, right? This, and this is what ISP cloud is. And then you would have a connection to the other end. So whenever you look at the black cable and understand that there are so many devices, we basically treat it as the underlay. Okay, or you can say SD-WAN underlay as well. And when you look at the IPsec tunnels that are going to be maintained, the IPsec tunnel will be called as overlay of the SD-WAN fabric. So when the communication between the site to site is actually done 10.x.x.x to 20.x.x.x, the communication from site to site will always be done via the overlay. It will never be done via underlay. But for the overlay to come up, your underlay actually must be pretty much reachable. If you have an issue in the underlay, then overlay will never work. You get that? So which comes to a conclusion that each router will form a data plane connection to the other routers within the SD-WAN overlay for the purpose of like transporting user data. And the data plane connections which are talking about, which are basically nothing but IPsec tunnels, they are only established between data plane devices. Okay, these tunnels are secured via IPsec, which comes to a conclusion that if you have your vManage, come on, if you have your vManage, vSmart, and vBond, you cannot have any IPsec tunnel with those devices because IPsec tunnels are only meant to be used for data plane connectivity and not for any other sort of connectivity. And there is another, you can say, thing that the tunnels are actually created automatically. As I told you, that Cisco Tech created a report that around 70% of their customers create tag tickets for connectivity not being up, for their site being down and not accessible. And then 90% of the issues from those customers are because of the misconfigs. So Cisco kind of took away the load from the user to actually configure phase one, phase two parameters and all of those things. And as soon as you provide underlay reachability, your IPsec tunnel will automatically be formed. There is no phase one config, phase two config that you need to do, or IK version one config or so that you need to do at all. The config is by default there with pretty top-notch encryption and encapsulation standards and all, and your IPsec tunnel will automatically come up. You don't need to manually onboard your IPsec tunnel at all. If the IP reachability is there, then the tunnel will come up. And apart from that, you can say there is something that is called as a protocol is used, which is called as BFD. BFD stands for bidirectional forwarding detection. Okay, so when we look at BFD, you can say BFD hello packets are sent from here to here, and if the hello packets are being acknowledged back, which means that the network is healthy and the IPsec tunnel will come up. So BFD hellos are sent in order to measure the link liveliness, okay, between all the WAN edges. And it basically calculates parameters like jitter or loss or delay factors, and then it is able to measure how the transport is actually performing, because you have features like application aware routing and all. For that your managed performance needs to be calculated so that the solution can figure out if the transport is performing within the expectations or not. And one more thing is, these hello packets do not need to be processed by the router, by the WAN edge. Okay, the hello packets can just be acknowledged back without processing it, because your WAN edge might be too busy handling lots of other things. So if it creates delay in processing the BFD hello, that can kind of indirectly measure a wrong parameter of how the WAN edge is performing. So that's why without BFD hellos being performed or being processed, your manage can just acknowledge the hellos to just specify whether the link is up or not. That because that's the only motive of BFD is sending hello. And this greatly reduces the CPU impact as well, because the neighbor doesn't need to process these packets. So by comparison, if the neighbor was involved in the processing of BFD packets, then the remote neighbor's CPU was busy with some other processing, then there could be potential delay in responding to those packets. But by eliminating this, you could basically be there could be potential delay in responding to those, and you can reduce the outage detection time to and improve the user experience, because that outage detection time or outage time would be false if it's so. So that's kind of an advantage of having BFDs being used in order to measure the link liveliness. Now, another thing that you need to understand is how the WAN actually works. So, how does it get the information? Because if I would like to explain you, the IPsec packets or IPsec tunnel is only maintained so that the actual user traffic can be sent from this end to the other end. Which means if you have a backend link or if you have a network 10.x.x.x and the network goes down, then the WAN needs to create an update and send it to the other devices. But these routing updates are not sent into the IPsec tunnel. The routing updates will be sent to some other tunnel to the controller, and it works like a BGP route reflector. Okay, your vantage is not responsible towards sending the routing updates to the other vanages. In this case, if there are like 100 of vanages that are connected, then your router will have to send the update to 100 others, and those 100 others will have to process that particular things. So you can see how many exchanges and how much of utilization would be there. Instead of that, the vantage is actually supposed to send that particular routing update to vSmart. vSmart updates the routing table and it just sends an update, nothing else. The vantage doesn't need to process that update and see what's wrong. It will be processed by the controller, and controller can take the decision and send any update, and then the new route or any route that needs to be withdrawn from the vantage will be done by the vantage only. But yeah, no need to be processed by your vantage. So that's another thing, which means the IPsec tunnels are only used for sending the user traffic, not any updates or nothing. That's one more thing that you can consider, and this is how the data plane actually works.